Jay, it's great to have you here on the road to autonomy. Oshkosh is world renowned for your design and your engineering prowess. The world's changing, it's going automated, and everything's becoming autonomous. How is Oshkosh as a company currently thinking about autonomy?
Thank you for having me. Really excited to talk to you about the impact Oshkosh has overall. So maybe a quick introduction to Oshkosh, and then I'll talk specifically about the autonomy question. We are an industrial technology company. We provide products for the everyday heroes, those who have the tough jobs in our neighborhoods, those who build, serve the communities and protect the communities, such as, your construction workers working at height, your refuse collection teams that actually come and maintain your neighborhoods, firefighters and soldiers and people that work at the tarmac at an airport where they work under all kinds of weather conditions in a dynamic environment. So those are the heroes that we talk about, and the world doesn't move on without them. So we talk about technology for the everyday heroes, and we are an industrial tech company that kind of always looks at the end user and make sure that our products are are serving the needs and making them safer, more productive, etc. So on the autonomy specific question, we talk about autonomy, not we think of autonomy not so much as something to replace a human being. That is really not the main vision of it. We talk about moments of autonomy, which means that applying autonomous technology where it adds the most value, rather than pursuing, let's just make it autonomy under all situations. Our vehicles are complex. They are, purpose built complex, and they're all there to do a job. They're not there for someone to go from a place A to a place B. They're people's offices. And there's a lot of complex controls that are involved as you get into these vehicles. And there are, as you think of a day in the life of, one of our heroes, there are quite often repetitive tasks. Many times it's hazardous. It's not the most safest place to be, and they're quite repetitive. And there's a lot of driver fatigue too, and the productivity, some precision requirements of the what they do. You're so in all of those cases, if you just apply autonomy in a targeted way, there is a tremendous amount of value to be had, in terms of, we are a B2B. Our direct customers can have total cost of ownership benefits. Clearly the end user has benefits in terms of safety, productivity. It just makes the entire value chain extremely efficient and safe. So we talk about moments of autonomy all the time. I can give you very specific examples of what I mean by that, but that's kind of how we think of autonomous solutions. And this applies across all our products. I can't think of one product where the moments of autonomy doesn't apply.
When you think about the moments of autonomy, and I love the line everyday heroes, how much of it is trying to unlock productivity gains and improve in safety as you're developing and even going into the lab of coming up with these new ideas for products?
It is majority of, so we do a very comprehensive voice of the customer, and because of who we are very close to a customer meaning not just our direct customer, the operators of our vehicles. We understand the pain points that they face. So we go through a very comprehensive voice of the customer, whether we spend time with our direct business customers or the operators of our vehicles. So we map what are the things that are inherently inefficient or unsafe about the work that they do, particularly repetitive tasks and the driver fatigue, injury, etc. Those types of things. We use that to prioritize where the autonomy can add benefit, or where technology can add a benefit, where the autonomy in particular can add benefit. Maybe and in so many ways, it is possible to quantify it. It isn't just a feeling. You can actually quantify it. We can actually dollarize the benefits, dollarize the issues that they have. One example I could give you is airports. When you land and your jet bridge your jet bridge that you need to, that first of all, many times you wait for a jet bridge operator to show up, and then it's a, I don't know if you've ever watched, it's a very complex thing to move. You're moving a entire building closer to a millions of dollars of aircraft, so they're very nervous to really make sure that they're not over indexing and they're aligning properly. And within a gate, there is different sizes of aircrafts come in. So doors are in different locations too many times for them to align too. And then it takes a lot of time for them to get trained. It's the training of the operators is actually quite tedious as well for them to really get good at. So you lose time in the process. Many times you lose time because they take a longer time to dock. Many times because they're not there. There's some and many times because there's an inclement weather outside that you can't do it. So every one of these things, there's a significant productivity loss, not to mention the impact it has on the passengers that fly. So these are the kind of things we prioritize. We work very closely with them. It's not just about what we do in our labs. I mean, what we do in our labs is the easier bit. It's really to understand and to really deploy technology. And then the last piece I would say is we work very closely with our customers to deploy technology early in the life cycle, so that we do get the feedback saying don't do this and do this, refinements that are required on these things. As an example, we have fire our next generation Volterra fire trucks in the hands of our customers, and they're on daily routes. We monitor seeing how they're doing. So that's where we further tune the product to make sure that it really meets the actual requirements of the use cycle. So that's how we think about it.
It's top of mind now. Everybody talks about tuning models, but you're tuning, if you want to use the buzzword now, physical AI, you're tuning it there. I'm curious, from an airport bridge, we've all been stuck. I've been stuck, I think, an hour once waiting for the individual to move the bridge. And let's just be very honest here. People on the plane get a little feisty after waiting a long period of time when they're after a long flight, because all they want to do is get off the plane. How close are we to automating the airport bridges?
We are very close to automating. The technology is already here. I could tell you that the technology actually identifies where the door is, and then it moves. I talk about the moments of autonomy. What all it needs to do is get very, very close to the door. Maybe last 5 inches from the door. Move the bridge, adjust the bridge its height, and get very, very close to the door. The last bit of the movement can be done by a human being. It's very easy to move the last few inches of it. So we are actively deploying JetDock technology across, and there's always further enhancements you could do. Technology isn't just a one thing. It's beginning of a platform. You can add more and more things to features and functions to it as you evolve. It's all physical AI. You saw a lot of AI at CES. It's all physical AI. It's actually where at the point of impact, making an impact. Again, we don't have to take humans out of these things. It's a matter of making. So any in that, let's imagine the scenario where a jet dock can get you there, 5 inches from the door, which means that, and the last bit a human being does that, which means that they don't have to go train skilled, wait for the skilled jet bridge person. They'll be more flexible in how they can deploy resources. And clearly there's a precision involved. There's a risk of damage to the aircraft is pretty much virtually minimized with this type of technology. So there's a lot of other benefits that happens. uh, and time is money, right? And then anytime your passengers can get off. So we have very specific time targets for the jet dock operation. So that's what we designed to, just to make sure that, and then you can always do things like you could have cameras within your. I'm taking you to the next level within your jet bridges, and you could see passengers coming on or off. Did the cleaning crew go in? Did the operations get done? There's things are possible to go beyond just docking the bridge, if you will. Oh, conditions inside the bridge. There's air conditioning, there's temperatures, there's a lot. lots possible as you start to build this platform. The future of what technology can do is pretty is very, very compelling cases to uh, to really add value to the to and make things more productive in the world.
There's a lot of ways to add value, and I'm going to follow your line of thinking and take it one step further. So you identified the labor shortage because of the training and certifications that have to go into it. Could we get to a hypothetical scenario in the future where perhaps one of the stewardesses or the pilot could do the last couple inches if they have the ability to see the camera to do it? Because that way you eliminate, oh, we have to wait for the person. Oh, that's going to be 10, 15. Oh, could we eventually see it be done from inside of the aircraft?
Theoretically, anything is possible. Technology would allow you to do that. So it's a question of what are all the requirements and regulations that come into it. There's a lot of these. I'm very humbled by the environment that at the aircraft, at the tarmac. There is a lot that happens. We just take it for granted that the plane lands and then somehow we'd like to get off very quickly. So there's a lot of variability and a lot of dynamic environment that happens. So yes, I mean today I think I've seen there's technologies where the controlling the tug vehicle for
Hmm.
how the aircraft gets tugged in, that happens from within the aircraft many times when it's tugged in. So there's things such things are possible, but the complexity of where all the aircraft is going to go, and we have to think through the whole value chain, before just deploying a technology just to make solve one specific problem. We got to make sure think of the bigger picture. So technology isn't stopping it. I don't believe what you're asking. It's a matter of what's the practical, pragmatic way for doing this, and is that the significant value? And I believe the low hanging fruit right now is making it a lot easier for the operator training and not have to depend on the training. That's a very first step. It's low hanging fruit. I see a lot of these types of low hanging fruits the technology can do, and that's what we're going after in Oshkosh. Let's just get through some of these things in the next few years. You can always keep adding more to it.
And that's the beauty about physical AI. You can keep adding on, or I'll use the child's term, a Lego block. You can always put an additional Lego block onto it. And then you know this very well, and a lot of this audience knows it. When you're dealing with airports and when you go on tarmac, different sorts of regulations that have to be abided by in different ways. The processes have to be done, the technology has to be developed. Is Oshkosh looking for further more on tarmac operations? Or are you staying pretty close to, if you want to call it, the hub, where the passengers, the terminal? How are you thinking about the overall on tarmac autonomy strategy?
So we are very much looking at the whole airport of the future would include moments of autonomy around the tarmac. We do our ground support equipment that we provide today, whether it's tug vehicles or whether it's tractors for cargo loaders, tractors, etc. Those are that's where we see also an opportunity. I know we talked a lot about the jet bridge, but even there's a lot of opportunity there because people aren't allowed to go out and by the way, it takes three people to land an aircraft, right? I mean, to park an aircraft, you need the two wing walkers, and you really need the person up front to get into there, and then you need to chalk the aircraft. The aircraft isn't chalked, nothing can happen. They can't open the door, nothing can happen until the aircraft is chalked. Those operations, if you think about it, it takes three people to kind of guide the aircraft. That can be very easily automated. So we showed the vision of a robotics platform that based off of something that we've done in defense application, where it can work under harsh conditions. It could be obviously it needs to know where it is and kind of guide the aircraft. It needs to know what type of aircraft it is and guide the aircraft appropriately. We see that. We see cargo loaders. Cargo loading can be done by a human being, but the cargo tractors always move from a place A to a place B. They go back and forth between the aircraft and where it gets unloaded. There's no reason why that cargo loaders going back and forth cannot be automated in that particular geofenced area. Cargo loading, we're automating it. Cargo loading, again, coming in, it will come get you as close as possible to the aircraft, and the last few inches can be done by human being. The same idea as our jet dock. So chalk paths, clearly chalking at the it could be done. So we showed all of these things at our vision of the airport of the future. Yeah, tremendous amount. Perimeter robots for security checks around the airfield. Looking for any foreign objects, looking for dead animals, looking for all of those types of things. Overall, security robots are extremely value add. They're all. It's not just about robotics. When I use the robot, it's AI. It's physical AI. Cameras and systems actually see what's going on and interpret what's going on, and actually make decisions on these things. It's all obviously connected solutions and AI based. So a lot of opportunities. It's very fertile ground for autonomy and creating value with autonomous solutions.
And then below that is the models that power the physical AI. How are you as CTO at Oshkosh? How are you thinking about models? Are you developing models in house, or are you using off the shelf models and building your own proprietary layer on top of it? How are you thinking about all these different models? Because you have an incredible wide variety of business. You have a defense business, you have your airport business, you have your civilian business. How are you thinking about that, especially as it relates to models?
So we do have a well thought through technology stack as I talk about deploying autonomy as an example. It is really about what we do pay attention to is how do we train the models, the data sets used to train the models is where we are very particular about using the right data sets that are proprietary, that we control, because these are proprietary applications. It's not the models themselves. There are times we actually use models that are commercially available, but it's the training of the data sets, and then the protection of the data information. Do you actually um, call it kind of cybersecurity, product cybersecurity? Do you actually save all the data? Do you save all the insights? Generally, making sure that we are collecting what is required and no more, and we are saving what is required and no more. So just make sure that, so that's where we pay a lot of attention to. It's really the integrity of the training of the data sets is, in my view, is more important. That's what we pay more attention to. That's where we provide the most safety of the AI systems.
You have to. I mean, you can make the argument, a lot of famed venture capitalists have make it. Everybody has all the data, but the proprietary data is the moat. And you're right about that, because proprietary data can allow you to do things. Do you generate that data from your various test courses, your test ranges, or do you put things out into the field? How are you generating that proprietary data to ensure that it stays with Oshkosh?
We collect our own data as we're going through our own comprehensive testing, and many times we work very closely with the customer. So it's depending on, and we anonymize the data, of course, as we're going through it. But so there's no substitute for looking and feeling right there at the. We do initially collect all the data with what we need, with our own test course, both in our labs and test courses, and also, and many times customers give us access to their facility for us to do our own testing as well. So that's another source of information that we collect. It depends on the product you're referring to.
But then that's underhinging all that is great partnerships and great relationships. When you have great partnerships and great relationships, you can do really good things. And you have the partnership with the Department of War. Are you
Yeah.
deploying any of these models in airtight environments?
Particularly in our defense applications, but I can't talk about that. But just there are applications that are yeah, that are confidential, that we would have applications there. But even in things like, if you come to Oshkosh sometime, we could show you is that we are working on the moments of autonomy on the refuse collection. It's kind of, if you think of your refuse truck, side loader truck that goes from a place, house to a house to a house to a house to a house, right? So the technology actually identifies that there is a refuse container in the curbside. It identifies and locates where it is, and it stops the vehicle. Either the driver can stop it, or it can automatically help the driver stop the vehicle. Then it automatically deploys the arm with a push of a button, and grabs the your bin. While it's unloading, it's actually looking at what's the content that's inside of it, and it's actually weighing it. The AI technology weighs it. Just so so we've got a closed course setup that we test these types of things, but then we actually go on. We ride with our operate with the with our customers and their fleet operators, and we actually our engineers go there with them for on a day route and collect the data as a part of it as well.
Wow, I'm just thinking about this from, I'm going to put my consumerism hat on. The amount of trend data that can be uncovered, that's a whole business into itself. Oh, this house is buying more this house is buying this. Oh, they cut back in this, they cut back in this. That's fascinating market intelligence data. So you have, let's call it your waste management business. I know I'm oversimplifying this, but the reason I want to highlight that, because at CES you introduced HARR-E. HARR-E is not a person. HARR-E is a robot who I think is cool that will remove your rubbish from your house. Talk about HARR-E, please.
So Harry is again robotics and autonomy. It's a concept of how it's really changing and revolutionizing refuse collection in a planned community. So it's not for everything. It's in a planned community, potentially in an airport, potentially in a university campus, potentially in state stadiums, etc. So it is. The idea is today the big trucks come every week and stop in every house and collect things. Why not turn it up on its head, where you do it on instead of it being every day of the week? Why not call it on demand? There are times you don't need to have it come every week. There are times you need probably two times a week. You don't store bags in your bin waiting for the week. So it's gonna on demand part of this, where it could come in and just like it's hailable. Just on your app, call it, it'll come to you. It can even come closer to your driveway, so it'll open its bin lid, and you drop your things in there. It's good for people who don't want to carry large refuse bags, because they're elderly people that they can't. It helps them as well, just in terms of it. And then what happens in the community, you don't have a noise in the morning. In my community, it's Friday mornings. Friday morning, you don't have the noise of the vehicles coming through. So this HARR-E robot collects it and goes into a central station, probably within or right outside the community. And then one of the big trucks can come and pick it up. It's much more efficient in terms of usage, and the cost of operations is much more efficient as you think about it. So Harry can also do, to your point, it can actually say this house make. It can learn a lot about the behaviors of the consumers as a part of it, right? This house does something every Thursday, or this house is three times a week, or so it can learn more and more about the operations. And as it's going through, there's a lot of it can observe around it. It can look for certain things that could be hazardous, a cat in a tree and call somebody, kind of thing. So it's going around looking for things. It's the whole visibility and perception of everything else that's going on, right? Vision and perception systems. It has a lot of tangential benefits too. So that's the concept of HARR-E. It's disruptive. It's a disruptive innovation, if you think about it.
But it creates a lot of value. Think about this as a parent on Christmas Day. Instead of having rubbish pile up outside, and you send 6 or 7 Harrys, and okay, away it goes. There's a great benefit there. Then I also see a benefit for master plan communities to be deployed there, because there are some communities that have been well documented. Oh, it's an eyesore. Oh, it's noise pollution. You eliminate all that. So you can make an argument that Harry increases the the quality of living.
Completely agree. And then particularly for those, as I said, those who are physically not able to carry and big bins, or push big bins, and not everybody can. And again, through bad weather, think about it. Think about, bad weather that they need to push a bin through. So taking everything to a curbside once a week, it seems like it's a bit of a dated idea that can be completely changed with technology as we're going through. But it's got technology applies only in certain things. Again, planned communities, it makes sense. Campuses, it makes sense. It's not for everything. One solution doesn't fit all, but it's a good way to think about as we're thinking through it. Harry has received a lot of interest from a lot of people. So it's been one of those. They're kind of asking us, when do you go to production with this? When can we buy it? So we're getting a lot of that kind of a request based off of CES too.
So if you look, let's just use a master plan community because it's one of the most logical places to deploy Harry, where you have let's call it a central rubbish station, which is beyond the perimeter. Then perhaps if you want to say, I'll put my Mr. Rogers hat on, you have your neighborhood. And do you have the delivery station next door? And perhaps Oshkosh makes a autonomous delivery bot. So when the UPS or Amazon packages come in, it goes in, and let's just call it Oshkosh delivery, stops at your house. Is that the next logical step for where this technology could go?
We showed the concept. Harry is a whole other application, but it isn't just about. If you think of the technology platforms that can be scaled up, we showed at CES. We are the leaders of delivery vehicles with the United States Postal Service, which is going to be the fairly large fleet and fairly large EV fleet as well. And it's not just about the vehicle; it's also, as I mentioned, it's purpose design, safety, visibility. Um, it is really one of the most modern vehicles that you'll see out there. And so we showed this vision of next generation of delivery. It's not specific about USPS per se. What does delivery could look like? That's where a combination of hairy technology to a delivery next generation delivery vehicles. Again, you can have autonomous operations within the perimeter of the depot, right, where the vehicle, somebody can hail the vehicles, it can come in, they can load these vehicles, and somebody can still drive it out. And then once it gets closer to a community, closer to a neighborhood, they can stop, and then they can have someone like a Harry deploy and go drop the packages off. Those are the kind of ideas that we shared, that we it was a concept. We unveiled those concepts at CES this year. So that's the next iteration of what is possible, particularly in the delivery space. And we do see a lot about, it's not one or the other. Maybe that's my message, is that it's always a combination of technology practically grounded on what the application is and what the situation is.
So if you look at different situations, you have different environments, as you clearly articulated during this podcast. You have different use cases, which raises a question of sensors and compute. How do you think about sensors and compute when you're looking at these different use cases? Let's look at Harry. You probably need less sensors, less compute than if you look at one of your very large and industrial autonomous applications. Yes, you're going to need a lot more sensors, a lot more compute. How do you think about that? Are you open to exploring new ideas based on new technologies, and you want to call it the use case and the environments and just the overall size of the vehicle?
Absolutely, you have to be. And we are, by the way, all these vehicles have a lot of sensors and a lot of controllers. So there are, we talk about intelligent. I mean, there's a tons of sensing and control, sensing, perception, controls, and actions kind of become a key part of it. So there are, I think I did mention the technology stack that kind of drives actions there. There are, within the technology stack, we talk about, I use the term make buy, loosely. Sensing platforms that we can, whether it's cameras or radars or lidars, that's where we try to draw on, where can we commonize that, where can we generate scale there. It all starts off with a software defined vehicle architecture that it can accept these sensing. So there's an opportunity. We will never make sensors. That's not our thing. But we want to make sure the requirements are understood and harmonized so that we get we get some scale. And then when it comes to some of the compute part of it, we do partner with every major compute company you can think of, and making sure that that is a part of the platform, that application. And then we focus more on the controlling the application side, implementation, verification, validation. System design, system integration is what we focus on, whereas we have partners for all of these other areas. And many times people say, why don't you just take it from here and put it on this? It's over engineered in so many cases, which you don't want to do, right? I get that all the time. Why don't you just go, and then our applications are different, that you have to make sure that you are taking into account the environment, this thing, the dust. Take example of dust that the construction is going to live in. You can't just throw a camera on there saying it's going to be okay. So you got to think through what technology stack sort of makes sense to what problem you're trying to solve. So we do have a very my other part of my I'm the CTO. I also have strategic sourcing. That's also my I'm actually a strategic sourcing officer for the company. What it enables you to do is think of sourcing. Obviously we source all day long. We buy lots of things. We have a very strong supply chain organization, but the strategic part of the sourcing is about thinking ahead and kind of creating the right level of engagement with our tech partners early in the life cycle, because you have to in many cases the vehicle has to adopt the technology available, whether it's a camera or a radar, the way we think about it. So it all has to come together in the right way. So strategic sourcing, having the right partnerships, is very essential as we think through to get scale and to control cost and to get the right technology for the right product. So that's where it comes together between sourcing and technology
You
development.
need harmony there, because you're right. You have to be able to, if you're going to source GPUs, you have to be able to source them. And you have to be able to source them at market price, not inflated price. There's a big difference there. And then if a new architecture comes around, if ARM comes out with an architecture, or if TPUs can start powering this, or if XYZ processing unit comes out, you have to be able to adapt to that. That's the thing, which is really great, because you have the insight to the technology and you have the insight to the sourcing. I want to go back in history here for a quick moment. Oshkosh is very famous for the military's leader follower program that's been declassified now. Did you learn a lot from that program from a technical standpoint? Has any of that, if you want to call it technical breakthroughs that occurred to that program, gone on to evolve into other Oshkosh products?
Oh yeah, that is the PLF leader follower program has been we have been doing that's actually level 5 autonomy, because it is in a closed course. It is in a bit of a controlled environment. It is a these are autonomous vehicles that follow one person driving a vehicle, and it's obviously for long convoys, things like providing safety and getting people out of the harm's way. We've got the largest fleet out there running, working with the Department of War. And the learnings have been having our defense business really helps us to kind of stay at the cutting edge of technology. There are many, many, many technologies that get deployed there. There's always read across into other applications too. Particularly in that particular case, you talked about an example, details of sensing perceptions, and where does radar and lidar fusion of sensing and the fusion of various sensors, what does that algorithm look like? Validation, that's a really big thing, big part of it. And then what do you do when your communications network doesn't work right? There's a lot of failure modes that can happen that you think through. The learning has been tremendous coming from that application. And that's true for even electrification. There was a defense has done a lot of work in electrification long time ago. So we to me, that's what makes Oshkosh unique, and that's our strength. Our product diversity, our end market diversity enables us to transfer tech from one to another, transfer learnings from one to another, both in what to do and what not to do, both aspects of it. And then really validation is it's all about validation, making sure that we understand how much to validate and exactly how to validate. And that's where the IP is many times is validation of your technology out there in the field.
That's what gives Oshkosh a massive competitive advantage in the market. At some point, I'm not going to put on my magic crystal ball over here and make a prediction, but I will say at some point, physical AI is going to have its ChatGPT moment. It's just a matter of time. And I think it's going to happen sooner rather than later. When that moment happens, where do you want Oshkosh to be?
I agree. It's beginning to happen, right? The conversation's changing. It's beginning to happen. So we see us as the company that's transforming lives of people, transforming at end markets, right? And that was the whole idea of the X of the future that we talked about. And it's not just about us. It's kind of about you know our partners. We don't provide every vehicle for every application. There's other, we need to be in conjunction with our entire ecosystem. It's really transforming the entire ecosystem, and we are the thought leaders, and that we want to be at the forefront of the transformation. We are the ones actually will be driving at the tip of the transformation, driving the transformation, and clearly being humble about it, and knowing that we don't know everything, and working very very closely with the leaders, our customers, who live this day in and day out, and making sure our solutions are practical, pragmatic, and implemented. And actually, most importantly, I would say, people don't care about technology, they care about what it does for them. So if it gets to that phase, I would call that a success. If they're getting in a vehicle, it's so intuitive, they don't even need to worry about whether it's autonomy or radar or LiDAR. It doesn't really matter. It just does the job for them. It helps them do their job more easily, more efficiently. To me, that's the vision we're trying to get to.
And when the technology does its job, everybody wins. You save lives, you increase productivity, and you unlock economic activity, which is really great for the global economy. Jay, this has been fantastic. I'll ask you one last thing. What is the future of Oshkosh? Because I know you've built, and you've been building since the early 1900s, and you can continue to build for another 100 plus years. What is the future of Oshkosh?
No, I will talk to again. We will be the company that transforms the end markets. We will be known as a, we are everywhere. You people may not recognize the specific brands, but we are everywhere. Where so we will be impacting communities and lives of people that build communities, that protect communities, and that serve communities. So we keep the world moving forward. So that is the future of Oshkosh. That's what we see us to be.
I'll summarize this way. Oshkosh is building the future. The future is bright. The future is autonomous. The future is Oshkosh. Jay, thank you so much for coming on the road to autonomy today.
Thank you. I appreciate it. Thank you.